Hello everyone, welcome you all to the next session that we have planned. That is simplifying the production path with the supply chain choreography by Suman from VMware. So let me add the Suman to the screen and we can start with. Hello Suman,
Yeah,
welcome to
hello
AWS
everyone.
Executive Depot.
Hi, welcome
Yeah,
Suman. Welcome to AWS
Hi
Users App
everyone.
Rajasthan.
Thanks
yeah.
for
Hope
having
you're
me
doing
in the
well.
meetup. Yeah,
Yeah,
I'm doing
hope
good.
you're
How
doing.
about you?
Yeah, we are good.
Yeah, we are
Yeah.
absolutely fine.
So yes, I think we can start with the session now instead of wasting more of time and head over to you, Vidhu. I think Vidhu, you are on mute.
Hello everyone. I'm Vidhu Shikhar Joshi, your host for today's session. I have been a part of AWS user group for almost a year now. We have hosted multiple sessions with our flagship event being OS Tech Conf 2021. And we are back with another wonderful session with our esteemed guest for today, Mr. Suman Chakraborty. Suman Chakraborty is working as a senior cloud native architect with VMware, helping customers in their app modernization and migration journey with Tanzu Kubernetes platform. Suman has been a distinguished speaker in multiple conferences such as Open Source Summit, Hashi Talks, DevOps India Summit, etc. He is actively involved in many tech communities such as CNCF, Data Management Group, Google Developers Group Bangalore, Docker India, and Collabnix, where he shares knowledge with open source community on DevOps, Kubernetes, serverless, and security topics through meetup events. Suman is certified on multiple Kubernetes certifications, KCNA, CKA, CKAD, CKS. Suman loves to travel and is big foodie by nature. So without any further delay, I would like to pass on the mic to you, Suman. Really excited about today's session, and I'm sure all our viewers feel the same. Over to you, Suman.
Thanks, Vidhu. And I'm glad to be part of this exciting session with the community for the AWS User Group Jaipur. So the topic for today, what I'm going to discuss is quite interesting. It's basically one of the most talk about topic, if I say, in the enter open source arena now. So it's more about discussing what supply chain is all about in the software delivery lifecycle and how we can simplify the overall supply chain process. So I don't need to give much introduction. Video is already given. Just to tell, I'm working as a senior cloud native architect at VMware, and I have been speaker in multiple tech conferences with Open Source Summit, Linux Foundation, Hashi Talks, DevOps India Summit, and Docker India as well. I have been involved in multiple meetup events where I mostly talk about technologies related to DevOps, cloud native tools, Kubernetes, and serverless. When I'm not coding or when I'm not in my workplace, I would love to travel around the world, and I'm a big foodie. So let's see quickly what's the agenda. So we will discuss about what software supply chain is all about and how we can define the path to production for having a software supply chain here. Then we will basically discuss about the difference between orchestration and the choreography. And we will introduce one of the tool which basically helps in simplifying this path to production workflow, which is Cartographer. We will understand the Cartographer design and the philosophies, and then we will basically go a little bit deep to understand the basic architecture, how what it is, and what are the and how it basically helps in basically deriving the complete workflow, or basically helping in making simplifying the path to production use case. And we will then set up Cartographer in our own platform, and we will see how we can basically work with Cartographer to help in creating multiple user defined templates to work with. So let us quickly see. So what is software supply chain? Okay, so software supply chain is anything which basically affects our softwares and basically helps in the timely delivery of the timely delivery of an software release actually. So traditionally, if we say a supply chain is anything that helps to deliver a product, it can include all the components which are using. So it is this kind of component which goes and affects your code directly in your development phase, and it can be iterated into your entire software lifecycle journey through the CI/CD pipeline that you are creating for the software, till right from the stage where the code is checked out and to the time it gets deployed to the production. So when we say of software supply chain, it's anything and everything that goes in basically creating, packaging, building, and deploying your software into your production environment. And it can include anything like your codes, the binaries that you're using for creating the software, and basically the repository from where your artifacts are fetched. Supply chain encompasses different parts beyond a single application, and it can include right from your build and packaging scripts, which is responsible for running your infrastructure where your application actually runs. And the software supply chain can includes information that one needs, whether he is from the dev side or from the operator side, to run the software without any risk. Traditionally, when we think about why we imbibe software supply chain kind of a concept, we need to understand what was the requirement prior to that. So initially, for building and delivering a software, there are a lot of assemblies required, and that would basically encompass right from checking your code from your source code repository, whether it's a GitHub or it can be any other source code management tool, right? Then basically building the image, pulling the image from pushing the image to the artifactory, creating a pipeline where you need to pull the image, run some kind of automation scripts to basically put the image and put it into your application, and is deployable by any particular platform such as Docker, Kubernetes, or or let's say Ansible, and then basically putting some kind of security around it, and then basically finally deploying it into the production. I mean, this kind of stages all were quite quite unstructured. I mean, there were not a single way you can basically make them put it into a kind of a staging kind of a scenario where you can do them one by one. So with supply chain, you basically take the steps and put it in a uh, much more choreographed fashion, so that each of these steps basically takes certain inputs, produces certain outputs, and that output goes as an input back to that but next step. So what happens here, your process get much more simplified. The security of concerns which was there basically now gets divided into different teams who are managing different parts of your platform, and so it becomes very easy for creating the software, building the software, putting some kind of an testing around that software, doing certain security checks, and then finally doing a deployment. So the entire support becomes seamless. Now, when we think about creating a software supply chain, what happens? The next thing that comes is defining the path, the complete workflow, how you're going to deploy the software into your environment. So that environment can be your development environment, it can be your production environment, it can be any environment where the software is usable by the end user. So this is where we define the path to production is scenario. So don't understand, I mean, it's not like it's always we are deploying softwares onto a production environment. It is mostly the term is synonymous in understanding that whenever we are building or constructing a particular software, we would be deploying that in some platform, whether it can be a development platform, it can be UAT, or it can be production. But ultimately our goal is always to basically make our software go live so that it is usable by the end users, and basically that helps us to generate some kind of revenue at the end of the day. So path to production is a way how we can basically codify the application value stream maps as it makes its way from the developer's laptop or a workstation to the production directly. And to address this complete developer experience gap, the path to production allow users to create a unified access point of tools which is required for your application to reach a customer facing environment. So this complete path basically starts from your continuous integration to do certain security scanning, to basically building an image, then basically doing again a set of security vulnerability scanning on the image that would be deployed, then basically going through certain approval process whether that image can be deployable in the platform or not, and then doing the final deployment actually. And then what happens actually in this case, when we define a path to production kind of a scenario, there are, though it looks to be a very simplified approach in creating the entire workflow, but it's actually a complex process, because here you have multiple tools that gets involved. And the main point here that comes is how you can create a compatibility part between the result that you are getting from tool A and producing that same, or providing that input to tool B. So that's why we need to template the whole process, how we are going to basically creating the entire path. And so the end result which it produce is a single pipeline that can be reused by each team. So you create a singular pipeline for your software lifecycle that can be used by different teams, and it should be in a way so that that particular pipeline process doesn't depend upon, or it doesn't it is not fixed using a set of tools. What I want to say, let's say for example, from the developer side, the development team is using GitHub as their source code management system. Now in other case, people may not have GitHub, they might use other source code management, let's say a Bitbucket. So your path to production workflow should not basically change with the changing tools or or the technologies that you're using across the entire workflow. So that is what I'm going to discuss in later part. Now, when we define how you're creating the path to production workflow, what normally comes is basically understanding the concept of orchestration versus choreography. This is very important to understand in this cycle, because when we are managing multiple stages, obviously you need some kind of a controller, some kind of a manager who does the job for you, right? Now, so often we come across the term orchestration. An orchestration is a process where there is kind of a controller who orchestrates different tasks together. That means with orchestration, he is applying certain kind of a logic that needs to be implemented across different phases of the workflow. So that same thing happens in the software delivery lifecycle phase also. So with orchestration, well, what you do, all communication goes through an orchestrator. He knows that when I need to trigger a process in stage A, and how a second function would be triggered in stage B. So he has the complete logic. Now, potentially, when we use kind of an orchestration based feature, we have many difficulties. First is that with orchestration, you have a very tight coupling between multiple stages in pipeline, and it is very difficult to actually segregate the different processes together. So there is no clear separation of concerns between the workloads that you are trying to manage by an orchestrated tool. And it is also difficult that you cannot basically add, modify, or push any new tools into the stage, because what happens with orchestration, you have an orchestrator that basically creates a logic with the tool that you're using in your lifecycle phase. So it is not possible actually. And so this leads to inconsistent path to production based scenario, because you don't you have or you are binded to a complete workflow where there is a fixed set of tools actually. And then you have linearity, or and the next thing that comes is basically the linearity of workflow breaks, because you don't have a consistent path to production. So what happens, you cannot actually create many different changes that is needed within that particular workflow scenario. While considering between the orchestration and the choreography, choreography is a term that comes again with the context of path to production. It's when you hear in a very basic, I mean, when you think about that, it would look to be very similar, but it's actually not similar. What choreography does is a different aspect. Choreography doesn't have any control on the tools or technologies that you're using across the multiple paths actually. So what happens in this case, you have to basically understand that whatever the output that you get from stage A to stage B, the choreographer will depend upon that output and it will instantiate the next stage. So it doesn't control actually the tools that you are using in this phase. Okay, so that means, let's say for example, there is a vulnerability that is introduced in one of your application image that you are deploying. What happens if it is in the case of orchestration? There would be some kind of a CI that would trigger some request to the orchestrator stating, hey, there is a vulnerability introduced, and this is a patch that need to be uh, put forward on on the base image, which would be used to build up your application. What orchestrator would do, it would basically trigger, let's say, in your case, you are using, uh, let's say, Docker file to build an image. So what it would do, it would basically replace the image that is there within the Docker file and then create a new image out of it. Okay. But in case of choreography, what's happening? Whenever there is a trigger that is coming, it choreographer doesn't know that there is a trigger, but the processes that it is orchestrating, automatically it would pick up that there is a patch which is needed, and it would automatically put the changes on a runtime to the tool which is needed to finally build the application. So that is the way. So with choreography, you are not binded to a set of technologies that you are using for your complete software delivery lifecycle. And with this concept, we would basically come across and introduce Cartographer. So Cartographer is one of the open source tool which is more Kubernetes native, and they providing a high modularity and scalability to define your software lifecycle chain. So what Cartographer do, it basically allows your app operators to create pre-approved path to production by integrating different Kubernetes resources with the elements of your existing tool chain. So Cartographer as a tool, if I say, is not directly controlling all your underlying tools that you're using in your environment. You can use any set of tools. Cartographer doesn't rely on tooling schema. What it relies is the output from that particular tooling schema that is coming and is fetched into a specific template. We will be discussing about what kind of templates they are all about. So Cartographer basically does a choreography of your supply chain resources that you're using, whether you're basically checking out the code from your source code registry, then doing a build of the source code to create an artifact image, doing a scanning of the particular build, and doing a testing and deploying. All this goes through an approved workflow, and it's completely an open source and CNCF tool and has been built at VMware. So the Cartographer maintainers are from VMware, and we always basically encourage community contributions. So there's a huge community that is, there's a community that is now also being contributing towards different development, different improvements that is there, that is needed in the tool. So when we think about Cartographer from a very high level, from 10,000 feet overview, so here it is, you have a complete supply chain where you define all the components that are being defined. And what happens, you can have multiple workloads. The workload can be a Java based workload, it can be a it can be a Golang or a Go based program, or it can be Python, or it can be .NET, it can be anything. It doesn't matter. What it matters is basically whether the the supply chain gets a specific trigger regarding to the kind of workload that you are trying to build, and that is what basically results in creating multiple resources in triggering the entire path to production workflow. And Cartographer basically is defined not only from the for the developer side, it is built both for your apps operator and the dev side. So it is more into the DevSecOps kind of an ecosystem where the dev is controlling the kind of workload that is would be deployed onto the platform, while the app operator is basically building the supply chain which would be needed to run that workload, basically helping in identifying all these pre-approved stages that I discussed in producing the workflow, creating the workload into the final deployable platform. So this is what, so Cartographer is basically a CNCF. It's also hosted under CNCF ecosystem, and under sorry, under the continuous integration and delivery group, along with other tools such as Concourse, GitLab, or if you're using Captain, K6. And also you can see, so this project is very new. It's just a 9 months old, as you can see, but it's now picking pace because I mean, software supply chain is a very uh, talk about subject in most of the organizations, and all the organizations has their own strategy of how they can basically secure this complete path to production for your applications. Okay, so let's discuss something around the design and philosophy. So how cartographer actually works. So cartographer basically is a bunch of custom resources that has been created, uh, uh, and basically they work in the form of a templates, and these resources are specified by templates. So cartographer objects can be categorized. So when we discuss on a very high level, so we discuss everything under some blueprints. So there can be two different blueprints. One can be a cluster supply chain and the other is a cluster delivery. And every blueprint has has an ownership that is defined. Cluster supply chain is owned by the workload. Workload is the part of the deliverable which is owned by the dev community, while deliverable is the part of the ownership that goes directly to the apps operator or to the platform engineer who is basically creating the supply chain. With regard to that ownership, there are specific valid templates that one can use to create this complete path to production scenario. And each template basically act as a wrapper for your existing Kubernetes resources. That means, let's say, for example, in my current pipeline, I'm using I'm using, let's say, a GitOps tool. It can be Argo CD, it can be Flux, which continuously monitors changes into your existing in existing source code repository and pulls changes whenever there are changes that happen into the source code. That changes goes into that changes as an with a kind of a template definition goes into the next stage, which is something called is defined by a cluster image template, and then basically it helps in building that image. So here again, here again, using cartographer, you don't restrict to any specific tools. It can be, you can use, let's say, Docker to build your image. You can use OCI compliant tools such as BuildPack, back, or you can use 𝐀𝐠𝐞𝐬𝐭 to basically build your image. And that final build image goes into something which is called as a cluster template. Cluster template, again, it's a final definition that basically defines how you're going to deploy your resources. And this entire thing is being defined or is being choreographed through a cluster supply chain. So let's break the basics. So cluster source template, what I define is basically a template which tells you how you would be instantiating your cluster supply chain, the supply chain process. So it can be, let's say, using any GitOps medium, like you can use Flux, you can use Argo CD to basically poll the changes that is happening in your source code. And this template requires two different definition. One is a URL path and the second is a revision path. This basically, these are the data which goes from your GitOps output actually. So URL path, revision path are the data from a Flux output for which is passed into this cartographer object. And then basically what happens, this complete information which goes into the spec definition is again categorized via workload definition, which you define inside the template. I mean, this particular, so whenever you are defining a cluster source template, it would be referring to a specific kind of an application, right? So that is how you define under the template definition. And this is basically the Flux object which you are defining in your actual Flux definition. So that same definition, you put it inside that particular template. So that is where you create the mapping between your source code repository and your GitOps tool that you're using. The second that comes is a cluster image template. So I have just given the link of this github.com. This is the path where you get the raw template that you can use actually. So the cluster image template is again that instructs your supply chain how you're going to instantiate building an image from your source code. That means, for example, this is the place where you'd ideally be running a Docker build process. Or let's say you would be, if you're using build pack, you would be running kind of an build process, like using kpack or pack, anything. I mean, it doesn't matter. You just have to create the final artifact image actually, and that image, the image that goes would be taken from kpack's status output, like this dot spec dot image dot status dot latest image path, and that so that complete image path would be something which would contain the registry slash your repository username and slash the image name. So that would be provided in this image path. And similarly, inside the template, you would be putting the kpack definition, because the kpack would be using kind of a service account. It would be using a kind of a builder configuration to push that image. So all these kpacks objects would be wrapped inside the template that you'd be using, so that cartographer can identify how to link this template with the kpack output that would be created. And specifically, some of the parameters or the attributes like image repo and name comes from a workload definition, which would be seen later. I mean, that is the basically the definition uh, which would be created by the developer, like what kind of an application he is going to build actually. And so every template that you create is contains some of the inputs that is passed from the previous template. So here in this case is the source.url path, which is provided by the cluster source template that was carried from the previous definition actually. So next is the cluster template. So cluster template again is something which is the final stage of your supply chain, that is basically instantiating a Kubernetes object creation. It can be a pod, it can be a deployment, it can be a service. If you're trying to build a serverless definition, it can be a Knative service as well. I mean, that is how you basically create that. And what happens actually using this particular cluster template, you define that what is the kind of an Kubernetes object you are going to create. Similar to that, the metadata definition that would be contained inside the cluster template would be something again which would be coming from the workload definition, because that is the metadata dot name, that is the name of the application that you are going to deploy, and that should match with the with whatever you define and the workload YAML file. But apart from that, let's say some other common definition. In this case, you are creating a service, so you need to expose a service. All the port definition has to be created actually. So that is how you define. So don't worry, I mean, things may look a little bit complex, because I mean, cartographer works mostly using the template concept, but we will go through a practical example, and I'll show you how we basically create this. So we define all the three important steps in basically building the image, and this together would now be combined into something called as the cluster supply chain. And this particular supply chain that goes and triggers the controller, which is basically the cartograph controller, that would be responsible in completely creating the entire workflow, like uh, checking out the code from the source code, building the image, deploying into the Kubernetes, and this entire workflow would be controlled by the supply chain template. And basically, this contains the entire definition that we have put in the previous two definitions, that contains the source provider informations, the image builder informations, and the deployment informations that basically contains. So you basically templatize the whole path inside this cluster supply chain, and this is the input that goes in triggering or running the cartographer controller to see how it works actually. So setting up cartographer is pretty easy. You need, so cartographer would be deployable on a Kubernetes platform only, because it works using a bunch of CRDs. So you need a minimum Kubernetes version of 1.19 and above, and you need to install cert manager. Cert manager is needed to basically integrate TLS certifications during runtime between different templates that are working in resource creations. So the setup is pretty easy. You just do a kubectl apply and you create that. So enough of talk. Let us basically now see how we can basically set up the whole cartographer and instantiate our first workload definition. So right now, what I am having is a time cluster. I have already just created it. So I just have two client customer. I'll be using the cartographer hyphen demo, and I'll just see if my nodes are up or not. Yeah, it's the nodes are up, and just see the pods are also running. Yes, it's running. So the first definition in this case, what I would do is basically install cert manager, because that would be needed. So there's a quick command where you can check where you can your cert manager is up or running or not, using this cert manager CTL tool, which is the client side tool, to check whether the cert manager has been installed or not. For my case, it is not installed, so I'll just go. So I have the path actually that I'll be using. Let me just, yeah. So this is a quick way to install cert manager. So I'll just quickly grab the configuration here, and I'll just apply that. So what it do, again, it basically creates a set of role bindings. It creates a set of service account that would be using, and a bunch of the deployment and the pods, along with the mutating webhook in this case. So it basically creates a namespace. In my case, it would be creating cert manager, and let me check if the pods are running, or maybe they are in, okay, they are in container creating state. So let's just keep a watch. Yeah, so yeah, the third one has also come. So right now the pods are running in the cert manager, and what I can do, I can quickly basically use a CMCTL to check, and it says the cert manager API is ready. That means one of the first prerequisite to basically set up cartographer is done, which is basically installing the cert manager. So next is basically I will grab and basically pull the cartographer definition here so as to install it. So let me again go. So this is the cartographer website. So GitHub repository. You can quickly check. I will put that in my slides as well. And this is the simplest way. So to use, you basically create a cartographer namespace. So I'll just create that, and then basically I will just go and quickly grab the definition to submit the objects in this with the cartographer system on the cartographer system namespace. So the latest is 0.3.0, which is running, and this basically deploys a set of bunch of Kubernetes resources, basically creating roles, cluster roles, issuing the certificate from the cert manager. So that's why the basically cert managers needed to create the self-signed certificate for the resources to talk with one another, and then it basically creates a cartographer webhook in this case. So let me check again. So I think the cartographer pod should now be up and running. Cartographer system. Yes, this is running now. So once you basically set it up, so you can see the bunch of CRs that are created. So I'll just do a grape carto. Yeah, and these are the definitions that would be used in the supply chain configurations that would be using. So these are the custom resources that are being created automatically when we submit the cartographer definition here inside definition while deploying it into a Kubernetes platform. So as I told you that everything works with respect to a blueprint. In the blueprint will be always divided into a workload definition and another is deliverable definition. Sorry, the workload is something which is managed by the dev team, because the dev is responsible for submitting what kind of an image for the application that he is trying to build would be submitted. So it can be a pre-baked image, or it can also basically create a definition of how that image has to be constructed, and deliverable is how that image would be taken and would be deployed actually. So this is the way how it would be done in a very simplified way. So let's see a practical example. So let's assume that our team has been given the task of building a game. Let's say the game is Pac-Man, okay, that we are going to build. And so let's see how we basically use the concept of supply chains to basically create and simplify the entire build process of building the application. So right now, what I have in my I have a few bunch of YAML definitions that I have created. There's a template definitions that we are going to use. Cartographer always basically helps. I mean, Cartographer is not meant, as I told, for the apps operator, but it also helps the dev to define what kind of an application that is going to be built here, right? So first thing that comes here is basically building the cluster template. So let's see what goes inside the cluster template. Default cluster template. So this is a cluster template that I'll be using. So what I am mentioning here that, okay, I'll be basically deploying an application, and this basically the deployment would be coming, would contain certain parameters. Let's say, for example, this is, so the first job is from the app operator side. So in this case, basically what happens here, they define that how the application is going to be deployed. So let's say I assume that I'll be deploying the application with minimum 3 replicas. So this value is constant, and so I fixed it. But there are few parameters which would be coming from the developer definition, which is from the workloads. So that's why I have basically created this kind of a reference, which we call as a supply reference to the workload definition, that what would be the app name that I'm going to create, what would be the label that I'm going to define for that particular app, and what would be the container name and image. So this is just a spec which I would be referring to the workload definition. But there is a certain way how that workload would be tied to this particular cluster template definition, and that is what we are going to define in the supply chain. So now we just have the base definition. So I'll just apply this base definition in my current environment. So what I get an app deploy created with a cluster template. Let's see what is there in this specific cluster template actually. So I'll just do a cluster template and app deploy. Sorry. So as you can see that this basically created a definition for me, and the most thing that is seen here is the operation. So the operation here says that update. That means it is waiting for some resources, some input for the resources that needs to be provided here, right? So that's why it is mention an update, and these are the specs or the definition that would be coming from the workload definition that I'd be putting it after some I mean that I'd be creating at later point of time. You can also query the same here, and you can see that app deploy has been created. Well, good. Next is what we need to basically create a set of permissions for our cartographer, so as to basically do certain operations of the on the object that we are creating, because this is a template. The cartographer still doesn't have permissions to do anything unless you specify. For that, what I have done, I'll be creating a kind of a I think the file name is cartographer permissions. Yeah. So what I will do, I'll basically create a service account, which cartographer will use in this case in the default namespace, because I'm creating the application in the default namespace. But here you have option. You can basically create and deploy this in your own namespace as well. I'll be creating a set of roles. The role would basically tell me that what action needs to be performed on that app that I'll be deploying. So you can basically list, create, update, delete, patch, watch, get. You can basically provide this action based on uh, what you intended to do with the application, or what is the permission that you want to provide to the cartographer to moderate your application. So here this gives more flexibility, because you can restrict the cartographer to basically access the object and do limited operations as well. And then basically you create a role binding specific to the role that I'm creating. So let's define this, create these definitions as well. So the service account role and role binding is created for the cartographer. Fine. Now what I have to do, I have to basically create a supply chain because I created a template. I created a set of roles, role bindings, service account permissions. But who is going to bind them together? The one which is going to bind them together is the cluster supply chain. Cluster supply chain is basically going to use the template reference cluster template which we created earlier. So this is the one which is going from the previous definition service account that we created for this specific cartographer to specify or access our object. And this is the important field. Selector workload type is pre-built. So this is the field based on which our workload our workload should have that same field, because once the dev submit a workload definition, the controller looks into this particular selector field. If it finds that this particular selector field is present in the cluster chain definitions, then the controller triggers the whole complete workflow process. So now what I will do, I'll just create this. Now the supply chain is created. So let's see what there is a supply chain. It's a supply chain and sorry, cluster supply chain, and the supply chain is name is supply hyphen chain. Sorry, the spelling errors. Sorry. Okay, so this supply chain is now ready. Okay, I mean it's now ready because it has got all the previous supply chain definitions that sorry, the template definition that it basically has reference to. So we can also describe this, and you can see. So this is important for the cartographer definition, that on the end the status, the conditions should be true. That means your template should be ready, because unless these templates are ready, you cannot actually instantiate any workload definition. This would actually refer to that particular the workload that you would be submitting. And this is also update, that is fine. And yeah, so this is the supply chain. That is the simplest thing that we have defined. Now, this basically ends the work of the app operator. You have already created a pre-paved path for your app to be deployed using that particular selector. Now, the application team comes into the picture. Basically, they have their own workload definitions that they would be creating, and that is again a carto definition, which is kind of a workload that you would be specifying. And I'd be basically building an application. So in my case, I'll be basically deploying a Pac-Man game. And this is important. See, this is the labels workload type pre-build. So if you remember what in the cluster supply chain, if you see, this specific selector has been given. So whenever you submit a workload definition, this labels is tagged or match with this selector that is defined in the cluster supply chain. That means you can have multiple supply chain created. You can create multiple workload definition, but you need to understand that which basically the path to which basically which supply chain you need to trigger. Based on that, you specify the workload and basically you deploy that. So here in this case, I have mentioned that I'll be using this supply chain because I have only one. And then basically the spec. So here, this is the image docker.io, which I'd be using from my registry. And this image output would go into somewhere in this definitions that we have mentioned earlier, which is this actually workload.spec.image. So as you can see, how the how we are going from a very much high level to a very low level view, where you specify the final input to the cluster supply chain resource, and that is what is needed. We need to basically minimize the complexity for the developer team. The developer doesn't need to understand the supply chain. What he or she needs to understand, that what is the selector that I need to create, and that same selector should match to the supply chain policy. And basically in this case, I will mention that, and the image that I'll be just using. So now let's define the workload. Yes, the workload has been defined. So you can describe the resource. And you can see that it has basically started creating. So you can see the resource submission complete. So this is important. So first is the supply chain is ready or not? Yes, it's ready. If it is not ready, the deployment would fail then and there, because without supply chain, the workload definition doesn't have any meaning. And then the next is whether the resource submission has been done or not. That means whatever the resource needed in the template has been given or not. So this resource submission has also been completed. Now let's see whether our deployment is done. Yeah, so the deployment, you can see out of three it's ready. We should see our pods should also be running. And then there is a nice workflow. I mean, then there's a nice tool which is called as a uh, 𝐾𝐞 tree, or the cube lineage, which basically shows you the hierarchy of the Kubernetes resources that you deploy. So in this case, I'll use that workload, and then I'll just give the name as Pacman. Oh, sorry, silly mistake. So as you can see, my workload Pacman contains a deployment Pacman deployment, which is ready. It created a replica set and then 3 pods, and all has been defined via this supply chain resource. Okay, so now if I'm going to check whether I'm able to access the application or not, I'll just expose the deployment. Let's say I expose to port 3000 to port 80. Sorry, it's deploy. Okay, so let's see if we can access the application. Let me open a browser. Or I can check here also. Yeah, HTTPS localhost 3000. Um, One moment. Why it's HTTPS? Should be HTTP. Yep. So as you can see, the app is now deployed, and basically this is as super as easy to do the deployment. I mean, because everything is controlled, you don't need to do any middleman work here, because you first create a supply chain, you first create the templates that would be referred by the supply chain, and then basically you use a workload to identify or to point to that particular supply chain to create that final deployment. So that is the way how you basically define that whole supply chain process actually. So yeah, that's all in the demo. So let me just move into my slides. Okay, so the conclusion. So why you should think about Cartographer? Because Cartographer helps application operation team to go beyond the normal CI/CD work process. In CI/CD, everything has to be integrated tightly with different technologies and tools that you would be using. With case of Cartographer, you don't think about the tools and technology. You just think about the final output that would be coming in terms of putting it or creating it as a template. And basically, it basically helps in maintainability and usability at a large, like when you would be scaling up, right? So it would be very easy to scale up, because you don't have to really think if the tools changes in midway in your complete supply chain workflow. Enhances the supply chain visibility with an event driven non-linear workflow and asynchronous processing. It doesn't have to be that you create the first the template, then the first supply chain. You can also create the supply chain first and then the template, but the workload would only act if there is a supply chain that has that particular level definitions together with it. It helps in adapting the work with loosely coupled supply chains made from independent components that can be updated on the file. So you can basically now update the image that you are using and again resubmit a workload definition. It would again basically create the complete work because the workflow is provided for you. It would just take that as input, provides the base input to the templates, and it would deploy the application. Cartographer supply chains are very much cloud native, so you can introduce updates and evolve own supply chains without impacting their availability. Boosting team productivity, as you can understand that divide we divide the scope of work uh, that need to be worked out in defining the supply chain. The app operator manages, maintains, creates a supply chain for you, while the dev side people, they define just the workload which needs to be deployed. They don't need to understand more on the platform side. Boost and then you can improve the security as well by providing much control onto the team who is accessing the supply chain, because now all the all the processes you can define via the RBAC access as well. You can provide some controls of what needs to be done on the resources that is being created, and then the consistent process apply to all the applications which move throughout the supply chain. So cartographer is completely an open source tool. If you're interested, you can definitely go and check out the website. You can go and involve by looking into the project, start by looking into the documentation, going through. If you think there can be a specific use case, you can submit the same. The cartographer team is quite active both in the Slack as well as in other social media handles. You can reach out to them. You can basically think about bring your own use case and integrate to make the supply chain more robust and workable for larger enterprise use cases as well. So that's conclude my presentation, and I hope that was useful with respect to the supply chain definition and how cartographer as a tool helps to simplify the whole process. Open to questions now. Thanks.
Yeah, thanks a lot, Suman, for the wonderful session. And this was quite an interesting topic also. Like we have got a lot of comments around it. So let me just speak one by one.
Sure.
So the first question we have from Jim is how it can help us to running workloads on AWS CKS. And they are
Okay.
deploying, I think it's from AWS CI/CD.
Okay. So, see, it doesn't actually depends on the technology that you're using. What, as I told you, like you just need to basically create a kind of a cluster supply chain configurations that would contains multiple template definitions, right? So if you're using, let's say, AWE case, you can basically create your cartographer on top of it, and then basically you can create a cluster template which would basically point to the resources that are coming from multiple other tools. Let's say if you're using Flux CD for your GitOps, you're using Buildpack for your image creations, if you're using let's say if you're using Aqua Sec for your security scanner, or let's say Trivi you're using for build, you can actually take the outputs and define that within the template and build it within the supply chain. That would basically help in creating the workflow even on AWS as well.
Okay, great. Yeah, so the next question also from, I think, Jim. Like, so
Yeah.
where to getting started from the cartographer?
Yeah, so I would suggest to start with the website. Maybe I just showed you. So this is the link, cartographer.sh. You can basically go and there are the documentation is quite good, and you can basically go through. Sorry. Yeah, so you can basically go through it. You can first check about what cartographer is all about. If you just need to go a little bit deeper, you can go to the architecture, and here you can understand all the blueprints, how the blueprint is defined as per the owner, and what are the templates can be used. This is a nice one to understand how the entire supply chain definitions is being created through cartographer. You can go through more complex use cases by creating more number of tools in the supply chain, but I would suggest you can think about and going through this tutorial, then through this architecture, and then going through the first hand tutorials, which is creating a supply chain here, and then basically how you are going to use different parameters, extending the supply chain. You get different, different scenarios. So the docs is the best, as I told you to start with.
Yeah, I think this is more of self-explanatory, if we say.
Yeah, and if you stumble across any issue, definitely you can reach out to the cartographer, maintainer teams. They are quite active in the Slack as well, even in the Twitter as well. So they would definitely help.
Yep, sure. So we have next question from the Isha. I think, like, can you share any brief about the prerequisites
Okay.
for this?
Yeah, I mean the brief to install Cartographer, there are no specific prerequisites. Just that there are two things. One is your Kubernetes version should be more than 1.19, either 1.19 or above that you can use. And second is that you need to have cert manager to be installed, because Cartographer uses manager to create self-signed certificates for the cluster Carto resources that it uses for the complete supply chain.
Yeah. Uh, so I think we are having next question from Murli. So, any workaround for simplifying the stuff by integrating it?
Only maybe I didn't get your question. So
I
workaround
think
for simplify.
so. I'm not, what I am thinking about this, like, so they might be having any of the running environment and they want something.
Okay.
Yeah. So like how they can integrate on running stuff, something like that.
Okay. So with respect to that, I mean, see, in this case, it is just the first time that you define the whole cluster supply chain. Cluster supply chain for your workload, right? So that is a one-time activity. After that, what you do, you basically create a workload definition. That workload definition would always identify that specific cluster chain based on the label, based on the selectors that you are basically defining within that workload. So if I understood your question correctly, so you can simplify by creating a complete supply chain for your application deployment, and then reusing that multiple times by using different selectors for the workloads that you are creating. In this way, you don't need to create a supply chain every time whenever you are deploying an application.
Okay. Okay. So is this only permit to AWS workloads or can we use the other cloud as well, kind
No,
of
no, no.
information?
I mean, it is possible for any. I mean, you can use any kind of workloads. Even I showed the demo on a kind cluster, so it is nowhere related to AWS. But you can run any workloads. As I told you, right? If you have a Java-based application, you can run that. If you have a Spring Boot Clinic applications, you can run that. If you have a Go application, Python, you can run any. Just be sure that whatever the type of workload that you're mentioning, that every workload should have a selector. That selector would identify the type of supply chain that would be used for uh, taking care of, for deploying that workload to the endpoint, right? I mean, to the deployable platform. So that should match. That's it. I mean, there's no other request.
Yeah. Okay. So the next question we have from the Sashwat. What
Yeah.
security implementation are necessary when configuring the templates?
Yeah, this is a nice question. So as I was telling that you can basically enhance your supply chain by integrating some of the security side aspect as well. Let's say, for example, you want your image to be scanned via Trivi, right? So you can basically create a template that would basically take the output of the Trivi output that is running, put it there, so that when the cluster supply chain gets triggered, it automatically takes control of what actions need to be performed. Let's say building, creating the pulling out the source code from the code repository, building the image, pushing it to the Docker registry, pulling it back, doing a scanning of that image, and then basically deploying that on the platform. So that can be built, and so you can actually add. So this is the diagram which I was showing. Possibly, let me show. Yeah. So here, as you can see, there can be n number of steps that you can use basically to trigger your supply chain. So it's not necessarily that you just create a workload, create a build image for that particular workload and then simply submit and deploy. You can basically do an endpoint integrations with that and put it into your supply chain policy. That is very well possible. And the only thing that would matter is whatever is needed from a cluster spec perspective, like what is the expected output. Let's say, for example, for a cluster image, the expected output should be the image path that would be needed. That is that is basically that is taken from whatever steps you are running. So that is mentioned. Then everything is fine. It can be easily implemented.
Okay, so next question we have from 𝐀𝐠𝐞𝐬𝐭. So also would suggest to for a complete fresher like me how to start learning this. So I think you have
Yeah,
already answered this, but yeah, please
yeah.
take it again.
I mean, see, I mean, to start with Cartographer, you can simply first understand what supply chain is all about, why we are actually using Cartographer in the first place. So, to basically give you a very very brief about like how you can start. Basically, you can think about the modern day security implications in the CI/CD pipelines. Where are the flaws that is coming and how one can mitigate that? Then understand what supply chain is all about, and then basically come here and understand Cartographer. But prior to that, what I would suggest that you need to have some knowledge around CI/CD as well as Kubernetes to understand some of the constructs that would be using within the cartographer. So that would be needed here.
Yeah, I think that answers the all of the questions, and we have got some good appreciations regarding the session also. Like
Yeah,
it was so good to have you there, and
yeah,
so let me just go ahead with the quiz part now because everyone is waiting for that
yeah.
itself. Yeah. So yeah. So let me share my screen once. Okay. Yeah. So what we will be doing is like we will be. I will just share you the one link, and what you guys have to do, you have to just go to that link and join the quiz. So when you will just in, I will get all the info here. And once everyone let in, then I will just start the quiz. So I think there will be around 10 to 15 questions you might get, and it will depending upon the like how quickly you can attempt those questions, not the right one or the wrong one. So just be quick, guys.
Fastest finger fast, something like that.
Yes.
Oh, so nice. People are joining.
Yeah, we'll wait for the 5 minutes to like everyone will join that, and we will start it. Okay, so we have seven now. Okay, so is anyone left or anyone facing any issues while joining the quiz, or shall we start this? Yeah, I think we can start now. So let me just start. Okay, so people are just answering the questions. I can see. So the question is more around of I can say open source CNCF and the projects they have in place.
Okay. Yeah.
Yeah, because this is more of like OSS we have, so we just designed the questions around that also. Okay, so I can see Abhishek Khandal is stopping the stream as of now. Okay, guys, is everyone done with the quiz? Let me just check the overall score. I think people are just answering some. Okay, so I'm not sure anyone will just come up now because the score is too much of Abhishek Khandal, Poonam, Tariq. Also, guys, if you have any questions, like you can just put on the chat and you can just join our Slack channel to get continuing with us, and you will get more updates on the Slack itself. I have shared, I think, already on the chat box, like how you can join us. Let me share the again. So that will be a good start to you all guys. Yeah, so you can go on this particular website and just heads up to any of the platform, and you'll get the info about the next sessions whenever we are planning something. So yeah, so we will be choosing only the top three winners from this list. So I think Shashwat is again trying something. So yeah, so I think we have Abhishek, Shashwat, and Poonam with us. So I'm just ending the quiz now, and let's see how it goes. Yes. So yeah, we have already like the three winners, the top three winners that I have already shown you. So all of the winners, you can just reach out to us
Nice.
on the. I'm just putting an email on the chat box, and then you can just heads up to us, and we will just share the goodies to you. Yeah, hope you like the session. Like hope you like the hosting also, Suman. And if you like the
Yeah, it
session,
was definitely good. Yeah. And I mean, the community was very much eager and enthusiastic about the topic, and there were very nice questions that came across. So I hope my session was useful. And I mean, this is just the start. I mean, but one can explore more around the supply chain. There are other tools in the CNCF ecosystem that also helps in basically securing the entire path to production for an application. But I think that I mean one can just start with this and can continue with other tools and technologies as well. Yep.
okay, got it. Yeah, thank you, Suman. Then we can just wrap it up. And yeah,
Thanks,
good to see
Aditya,
you.
and
Yeah,
yeah, thanks Aditya for hosting, and kudos to the community for coming on a weekend for attending the session. Yeah,
yeah, yeah. Thanks a lot, like giving us time and be here. Looking forward to meet you again in another
yeah, sure,
chapter or somewhere.
sure.
Sure. Okay then. Thank you. Yeah.
Thanks everyone. Bye.
Yeah. Bye bye.